If there's one product in the RV space that I think needs to be improved more than anything else, it would be the rooftop air conditioner. These things are loud, inefficient, and honestly, a couple generations behind residential technology. But now, that's starting to change. So here it is. This is the first unit I've been able to get my hands on that packs inverter-based technology in an RV rooftop unit. This is the first time I'm actually going to be able to test this, and something I've been looking forward to for a long time. If you followed our channel in the past, you've seen me attempt to quiet down and make old air conditioners more efficient, and I didn't have a whole lot of luck with that. It really is going to take a drastic redesign of the air conditioner to improve these things, and this one might just do that. Before we get into this model, let's talk high level about RV and residential air conditioners. RV air conditioners are typically roof mounted because that's where the space is for us to install them. A lot of people are converting to what's called a mini split on their RV because they are residential based air conditioners that you can make work in a lot of RVs, and they are crazy efficient comparatively speaking, and they don't require roof space. So if you want to put solar on the roof, this can be a great option. I really wanted to do this in our RV, but our RV design just wasn't suited for the mini split conversion. So I was really wanting to see some new technology arrive in rooftop units. Basically, this unit is packing similar technology to what's in most mini split air conditioners, but in the rooftop unit, the first time that I've seen it. This word, inverter, on an air conditioner, you see it on mini splits, and you're gonna see it on the newer RV air conditioners going forward because it just makes them that much better. Basically means that this thing has the ability to slow its compressor and fan down to match the cooling requirement instead of just on, off, which can create more noise, lower efficiency, and generally a less optimized air conditioner. Now, inverter is a bit of a misnomer because inverter means it's converting DC to AC typically, but really this is more a variable frequency drive unit, meaning that it can vary that compressor based upon its needs. This unit is the Turbo Greenland inverter unit. It is a direct from China product, but Turbro has been making mini splits for a while, and they've basically taken that technology from the mini splits and packed it into one of these things. Because I've never seen their brand in the RV space before, I'm not exactly sure how it's going to perform. I'm guessing this is based on a unit from some other products coming out of China. It looks almost identical to every other RV air conditioner general design that I've seen out there, but it definitely has some different electronics and technology inside it. We are going to open this thing up, take a look inside. We're going to install some monitoring on the existing Dometic Duo Therm. Yeah, it's a pretty old unit, but still working fine air conditioner that's in the coach. Take a bunch of data off it and then install the same monitoring on this and be able to compare and contrast if the inverter unit actually is improving our efficiency. And the biggest thing, sound. Sound is so important in an RV. It's such a small space, and these have a lot of challenges with airflow in a small space, that getting that airflow to be quieter can be really challenging. But this should hopefully be able to slow those fans and compressor down, which hopefully will quiet it down as well. Now, this unit is a non-ducted unit, meaning that it has this internal airflow portion, and there's actually a screen inside here, but I'm not going to be able to use this because our coach is ducted. So I'm going to have to do some heavy modification to make this work. So it might not be a like for like how it would work in an RV that's non-ducted, but I'm going to figure out a way to make this work, and it's going to be an interesting project regardless. I am super excited to try this out, so let's open this thing up and take a look inside. All right, we opened it up. I don't think we technically have to open it to install it, but here's kind of what we're looking at. I like that they've added quite a bit of condenser on the outside with the upward facing fan. This looks like a really nice fan design with noise silencing blades. This is the inverter unit. Looking at the control schematic here, we can see the indoor blower unit does not appear to be on the inverter control, so it must just be a fixed speed. But the indoor unit and the outdoor fans are totally separated, which is going to allow for a much more efficient design. There is a sensor on the evaporator, and there's also one on the intake, so they are taking a lot of data to try to make this thing run more efficient. It is just a capillary valve system. It's filled with R32, which is a much more efficient refrigerant, but not as common in the States yet. These are probably just vibration dampeners. It appears that this thing is actually sitting on metal springs. This thing is the compressor. And then this is the valve, the changeover valve for heat pump versus air conditioner. I like that it's in all in insulating foam for the air box itself. And overall, I'm actually pretty impressed with the build quality, I must say. This is, here we go, better look at that fan. Interesting design. Can't wait to get it hooked up. All right, now let's take a look at this interior portion that I'm not gonna be using. This is the actual kind of clip-on piece. It has this little piece of electronics, because that's actually a screen to give you information. I'm gonna have to take this off and put it somewhere else, because I won't be using any of this portion. That's the airflow distribution. We're just gonna be dumping the air out this one hole here. This is the air return, or no, this is the air return. This is the supply air into the coach. And you can see that this is relatively small, like the existing Duo Therm, but this unit is what clamps onto the ceiling to clamp the unit down. I'll probably use this, but I won't be using that lower unit. You can see it's got LED lights in here. That's kind of an interesting thing. That's what it looks like if you're gonna be using it. Normally, there was a piece of electronics in here that I pulled out already, because I'm gonna have to put that somewhere else because the duct is in the way in my case. So I'm reconfiguring this, but if you're gonna be installing this unit, that's what that indoor portion looks like. It does look like it just dumps air down into this. Not really a lot of air guide, a little bit here to kind of force air to go forward and backward. I'm guessing that's not gonna have a lot of quieting effect, but maybe the fan wheel itself is quieter. We're gonna find out. And a quick look underneath the unit. Here's the intake. The outflow looks almost identical to other RV air conditioners, and then just some foam padding to hold it up, and then the compressor's mounted on those bolts right there. So I definitely don't think you have to open this thing to install it, because the bolts should just screw up into these little holes at the corners. I'm gonna have to go ahead and print a duct though to make this work. All right, time to go inside and take some data off of the old unit before we replace it. Okay, so our air conditioners are ducted in this coach, and that means that they dump the air into a duct that runs down the center, and you can see it dumps out in a couple different places and like vents throughout the whole RV. Now, in ducted coaches, the air conditioner needs to connect to that duct somehow, and this one's not designed for this. And this big duct is in the way of everything we're working on, so I'm gonna have to create an adapter. I've already wired this one up though to take a bunch of data. Let me flip the camera around and show you what I've done. So the existing air conditioner is up inside there. You guys see Duo Therm right there. What I've got in here is a static pressure meter so that I can take how much pressure is in the duct. This is a hot wire anemometer that I've got stuck in the duct, and this is going to calculate airflow. Is actually going to calculate velocity, and then we can calculate airflow based on the duct size, because there's a little tiny duct coming out of this unit, and that's what I need to make a new duct for. And then I'm taking power. So this is a CT on the power line. We're taking voltage and current. And then this we can actually calculate power factor on as well, which we'll talk a little bit more about later. And then I'm taking temperature off of these units, one inside the duct dumping into the RV, and one just right here where the air just flows up into this to get to the existing unit. So I can calculate between the air input and the air output of this air conditioner how much capacity it's putting out. So I'm gonna write some special code to pull all this information, and then we're going to run this air conditioner on its own so the other two air conditioners are not affected by it. We're also gonna take sound measurements on this, because this unit is the one that I didn't do any sound dampening on. In a previous video you saw on that one and the one in the bedroom, I've already attempted some sound dampening. Let's get some data. All right, so as not to bore everybody, I'm gonna breeze through this pretty quick, but I do want to show you what I did to get this data. I basically wrote a script that pulls the data from all the wireless devices that I installed up there. We're pulling power, we're pulling airflow, we're pulling temperature data, and then we're doing some calculations on it. We're taking the size of the duct and the airflow to calculate the CFM, the cubic feet per minute of airflow. Then we're using that and the temperature differential to calculate the BTU per hour, how many BTUs the air conditioner is actually able to move out of the air or change. We're also taking that data then and calculating the EER, the energy efficiency ratio of the air conditioner. Now, I think my calculations are correct. You're welcome to take a look at this. I'll put all this information in the article that'll go along with this, but I'm going to use the same script for both runs. So even if I'm off a little bit, and also I don't know how these are originally tested, so this data is going to work for this particular use case. I don't think we can say that this is going to be completely accurate for RV air conditioners as a whole, but it should give us a really good comparison between the two. I basically ran this script, took a whole bunch of data, put it into a spreadsheet that then I was able to graph the data and make some assumptions based on what we saw. Now that we've got our data, let's take out the old unit.
Whoa, that's a big bolt, screw.
Whoops. So I know this is non-standard, but I'll show you what I'm doing real quick. The duct that we've got here, I'm trying to adapt it to the other units. So this is the little 3D printed duct that I made that will sit here. I got to cut this back a little bit, and you can see it's going to shift over the duct position to the corner, where on this unit, this duct is at this very far corner. So it's basically going to do that and dump the air into the middle of our duct. Another thing I built, and this is going to be something that we're going to have to test against a different air conditioner to see if it actually works, but this is an air turner. See the little wings on there? So this is going to help direct the air 90 degrees into the ducts. I think this will help make it more efficient and better airflow. This, of course, adding this before the fact will kind of invalidate some of our data comparing the existing one, if this helps. So maybe this is a future video. That is our challenge now, and I'm also trying to resurrect our water capture system. So in this coach, we have this hose that actually drains the condensate so it doesn't drip out on the roof and the gutter system. And unfortunately, this does fit nicely on this new unit with the little drains, but it's too tall. So I need to try and get some more foam to lift this air conditioner up just a little bit more, which is how the other ones were installed. So more modifications, but we're gonna make it work. So we've had the air conditioner installed for about a month now. We've experienced hot temperatures, we've experienced cold temperatures. It's actually really cold right now, about 50 degrees. The coldest we've seen is about 46 degrees, but we've run it both in air conditioner and heat pump mode. We're gonna take a look at the data here in a second, but overall, it's a huge improvement. Just the feel of how it actually works is so much better than the fixed speed air conditioner, because it can really find the appropriate temperature and then kind of maintain it so much better. It can ramp itself down or up depending on the needs, and it just is able to maintain temperature so much better. I like the performance of this air conditioner so much that I've already decided I will probably never buy a fixed speed air conditioner again, because it's just that much better and it just makes so much sense. Let's take a look at a little bit of the data that we actually pulled off it. So let's recap on the original air conditioner. We were really only able to get at maximum close to 9,000 BTUs out of the unit. And that equated to an EER, or an energy efficiency ratio. We calculated an EER of around 5.5, 5.6 at maximum for this air conditioner. So even though it's a 15,000 BTU unit, this is pretty pathetic. And we were seeing reactive power upwards of 400 watts on this old unit. On low fan speeds around 320 watts. We'll talk about what that reactive power means here in a minute. The old air conditioner did work really well in heat pump mode. We saw almost 17,000 BTUs out of it. Again, that's probably because that evaporator unit is the limiting factor on these air conditioners. We'll talk about that in a little bit further as well. But let's take a look at the new unit. What's so cool about this unit is how low it can ramp down and how high it can ramp. Now, we ran it at full out for quite a while, and the unit maxed out around 12,500 BTUs. So getting pretty close to that 13.5. Didn't quite make it in cooling, but it got pretty close and it put out an EER of around 11.5. So we're talking 2 times the efficiency. Again, all the same monitoring system, one versus the other. So while this isn't laboratory data, this is actually installed in the coach data, and this is what we're seeing. So Turbro claims an EER of 11.3. That's pretty much what I measured, which is pretty impressive. We actually measured far beyond that in when it actually ramps down. So that's pretty neat. We saw a maximum power in cooling of about 1100 watts. So much more efficient, and it's noticeable. We're getting almost twice the cooling capacity, well, not quite twice the cooling, but significantly more cooling capacity with significant less power, and it's just noticeable. We have had to run second ACs very infrequently, and that one AC is doing most of the work for both heating and cooling this 45-foot motorhome, which is kind of mind-blowing. We've barely run any of the other ACs. Now, the unit's lowest ramp, where it was able to run down to about 400 watts or so. 400 to 500 watts was what it kind of ramped down to, and that was about 8,000 BTUs that we saw. That EER came out to around 18, which is really high. Around some of the best air conditioners high. So I don't quite know if my data is a little off there, but that's what we captured, and it's pretty impressive. And it does feel like it's crazy efficient when it ramps down. It's just able to put out nice cold air and use so little power. This new unit also had a much bigger temperature drop, higher airflow overall. This Turbro unit was able to drop the temperature 45 plus degrees, and basically its limiting factor seems to be that it might be freezing up inside. It actually starts to back itself down as the indoor temperature starts to drop when it's ramped all the way up, not necessarily because it can't get there, but because it's preventing that internal evaporator from freezing up. And it's doing that by ramping the compressor down instead of what a fixed unit has to do, which is actually turn off altogether and let that unit warm up, and it has to cycle over and over. And that's a very inefficient process. Allowing it to ramp down, this can run so much more efficiently at its maximum capability. Now, that evaporator inside is relatively small, and that is where the limiting factor in most of these RV air conditioners comes from, is that there's just not enough airflow over such a small area to prevent that from freezing up. And that's also why we're able to see so much higher BTUs in the heat pump mode, because There's no freezing concerns with that little evaporator unit, which becomes the condenser unit in heat pump mode, and the exterior fins are so much larger on these units compared to the interior units that in heat pump mode, these can put out so much more capacity. We also ran the Turbro in heat pump mode down to 46 degrees, and it didn't seem to have any trouble whatsoever. Every other heat pump we've run in RVs has struggled when it gets down into the 40s. This unit's actually rated to be able to cool down to 20 degrees below freezing. In theory, a well-designed heat pump should be able to do this, which is really cool. So they actually say 19.4 degrees is how low this unit can go in heating mode. If we get to experience below freezing temperatures, I'll definitely test this out, see if it can actually perform below freezing, and I'll let you know in the comments. Now, we talked a little bit about that reactive power earlier. Let's come back to that real quick. Reactive power is what we engineers actually call imaginary power, because it kind of is imaginary. You won't actually see reactive power on most power meters in residential applications. Power factor is something we really concern more with at industrial scales. I, in fact, have done many jobs in the past where my job was to improve power factor, basically try to make that imaginary power disappear. This is power that is seen by the generation, so the grid in the case of you being plugged into the grid, but it doesn't really have to be there. It's a very complicated topic, and I'm not going to get into the details, but I was able to measure that reactive power on both the old air conditioner and the new unit. This doesn't really mean anything to you if you're plugged into the grid, because you're not being charged for reactive power from a residential application, but a generator or an inverter is going to actually feel that reactive power load. So if we can reduce or eliminate that reactive power, that load is going to be so much easier for the generator to run. This new Turbro unit, because it's an inverted unit, had only about 50 watts of reactive power compared to the 300 to 400 watts of the original unit. The reason for that is that the inverter that sits between the power supply and the compressor is correcting for that power factor. It is probably turning the power into like a 3-phase that's super efficient to run that compressor, and it's not seeing the inductive load or the offset power on the supply side. So what this means is that if you run this air conditioner on a generator or on an inverter or on solar power via an inverter, it's going to be even more efficient than 2 times, because your actual generation isn't going to have to put out that reactive power. This is something that is going to be a game changer with inverted units compared to a fixed speed unit for personal power systems and generation. This is partially why mini splits as a whole are so popular for people running solar power. They might not even realize that it's the reactive loads that is saving them so much energy, but the reactive load is part of power. And in inverters, a lot of times they're rated for VARs or even generators, and that VAR includes the reactive component. A Victron inverter, if you look at it, has a VAR rating of 3000. That's not watts, that's VARs. So this is going to be so much easier on these power systems, and that is pretty cool. All right, we've established it's crazy efficient. It works so much better. What about the sound? This is an area that I wasn't as impressed with. It definitely is better. It's a different tone than the old unit. I don't think this unit is necessarily a game changer. It uses the same airbox as most air conditioners out there. I think this is the exact same air conditioner design as some fixed speed units, so there isn't really a whole lot of sound benefit on the inside, but exterior sound is significantly reduced. The compressor sound is practically gone, but it seems like because that primary fan for drawing the outside air in is going up. Most of the sound goes up. So from the sides of the RV, this thing is crazy quiet outside, and that's really nice. It probably is partially helping to reduce that interior sound as well by shooting that sound up instead of out to the sides or directly onto the roof. Definitely on the outside, that variable speed fan, that variable speed compressor, it's able to ramp down and it sounds so much better than that compressor kicking on. It's just a much more pleasant sound to listen to in the RV. But I do think it's a little half-baked in that we should be able to vary the internal fan as well. Again, it can manage all of this to figure out what speeds it can run, what the airflow is, and not freeze up that evaporator. We were originally measured a 67 decibel sound on the original air conditioner. This was done with the Nyosha sound app on an iPhone, so we're not professional sound measurements here, but everything was measured with the same app from the same distance of about 3 feet away, directly underneath it. So 67 outside. The new unit, we only saw about 58 decibels, significantly reduced. But we actually were able to reduce that even further with a little extra sound dampening like we've done with our other air conditioners in here around it, to 52. Now keep in mind, this is a ducted system in this coach, so this is going to be different in with using the non-ducted plate underneath it. But it definitely sounded better than these old units. It didn't, and it doesn't have that horrible startup sound. It actually ramps up. It's kind of hear it instead of just bang and that compressor's on. On their website, they do claim 45 decibels for sound. I mean, maybe it's my meter, but that seems a little extreme. Says others 52 to 62. Okay, we measured much higher, so I don't know. Maybe, their drop is kind of around there, but I wouldn't say that it is the quietest unit. There's definitely room for improvement in sound. Something you need to keep in mind with this unit is that you can only control it with the remote or the app on your phone. Now, the app works extremely well. I've never had a problem with it once I got it hooked up to Wi-Fi, just following the instructions. It has always been able to control it. You can control any temperature setting, any mode. It does have a dehumidify mode, heat mode, cool mode, fan mode. That works great, but it has no feedback. So that means that the IR remote that comes with it doesn't get that feedback to it. So it might be in a completely different mode than what you set on your phone. So sometimes you have to actually make a change on either remote for it to apply that to the unit. It can be a little bit weird to figure out. You're also not going to be able to hook this into an existing RV control system as far as I can tell. There's no CAN bus, Ethernet out, anything like that. So keep that in mind, but the control system does work very well overall. Haven't had any trouble with that. The unit does have a little bit of a weird thing in heat pump mode. It doesn't have the capability to force the fan on. So if it reaches the set heat point, it will shut the fan off. In cool mode, you can leave the fan on all the time, which we prefer for sleeping because it's just nice not to hear that fan kick on and off. And this unit works great for that, but in heat pump mode, it does kick that fan on and off, and there's no control for that. A little frustrating, but hasn't been really the end of the world. It is quieter overall, so that's great. The unit does have kind of a weird feature in that it has lights in the actual ceiling unit. If you were using it in a non-ducted configuration, you could actually turn those on. I think it was blue, yellow, white, and red, maybe. Little weird. I don't think we're ever going to use that, but kind of a neat feature. So what do I actually think of the unit? What about longevity? I can't really say. I mean, it's a brand new unit. I'm guessing they just took mini split components and crammed them into this kind of traditional air conditioner. I'm a little concerned that the inverter portion is just kind of hanging out in the hot outer box. This is kind of how most mini splits are done though, so hopefully it's going to be able to sustain that just fine, but electronics and heat typically don't get along, so don't know longevity on the inverter portion in that exterior unit. It is running R32, which is partially how this thing is so incredibly efficient, is that is a much more efficient refrigerant. R32 is probably going to be a legal refrigerant for at least a couple years. Really shouldn't mean anything to you right now. One thing they did do for longevity is they did coat those exterior fins in some sort of anti-corrosion substance that they're kind of like blue. That's what that blueness is. That is an important thing. We are very near the beach here. We are in a salt air environment, and air conditioners around here corrode like crazy. We see them on all the houses. The fins are always corroding and coming apart. So seeing that anti-corrosion on the fins is definitely good to see. That'll hopefully make it last longer. Typically RV air conditioners don't see that much use though. So I don't know if that's really going to be a benefit or not. I can't really comment on longevity without actually continuing to use it. I'll definitely post if I have any issues in the comments for as long as I run this air conditioner. But it seems like a decently built unit, but it also seems a little half-baked, and then it's just kind of these components crammed into an existing air conditioner. In theory, it should work. It has been working great for us, and we haven't had any issues that we can note as of yet. Overall, I really like the low profile design. I like that fan that shoots up exterior. I do think there's room for improvement in the internal air distribution and possibly varying that internal fan. But we also have to consider the price of this unit. This is actually a very cost-effective unit. As of this video, coming in a little over $1,000 for this unit is pretty impressive for what you get. Turbro's told me that they'll provide a discount code for our subscribers, so take a look and see if they do have a discount code in the description below. Check it out. It does what it says it does, and that's pretty cool. Now, some of you might be saying, but Tom, this isn't the first time we've seen variable speed units, and don't you even have one on your air conditioner? If you caught that, you are correct. We have a 12-volt unit on our truck camper, and it is fully variable. Even the inside fan is fully variable, and that is because it already is an inverter converting that 12 volts into the power needed for the compressor, and it does work extremely well, and it is insanely efficient already. That DC powered air conditioners in 12, 24, or 48 volts, all of those should be variable already, but we haven't seen that technology come to the 110 volt side for bigger air conditioners, the 13.5 or the 15K. Why they come up with those sizes, I have no idea, but those size units that can really run on a larger RV. It just doesn't make sense for me to put a 24 or 48 volt air conditioner on this coach when the only time I'm really going to be running these air conditioners is when I'm plugged in or running a generator. On our truck camper, where we're off grid all the time, and it doesn't even make sense for us to plug in at a campground because we just don't need to, that DC air conditioner really makes sense for us in that situation. That's a whole nother animal. We're really talking inverted air conditioners, variable speed air conditioners, and heat pumps. By the way, a heat pump and air conditioner is the same thing. It's just terminology. A heat pump moves heat from one area to another. Air conditioner does the same thing. These units are basically taking the mini split technology and putting it into a all-in-one rooftop unit. No, it's not a split unit, but it's got the same tech in it. And I'm really excited to see this finally becoming available. This is just the tip of the iceberg. They were the first to market that I could find with an inverted 110 volt unit. But other manufacturers are coming out with these inverter units, and this hopefully is going to become the standard for RV air conditioners going forward, and hopefully we're going to see just further improvements from here. So definitely stay tuned, subscribed. I will be testing out additional inverted based RV units as they become available, because I think this is really cool and I'm excited to see where the industry is finally going. So as always, thank you so much for joining us here on Morton's On the Move for all of our crazy projects. And let me know if you want to see more air conditioner testing. Please like, subscribe, head over to our website as well. We have tons of RV information over there, thousands of articles. Subscribe to our newsletter over there. We publish new content almost every single day over there. We'd love to have you join the crew. Stay safe, and we'll see y'all down the road.